Hello students, today we will discuss the PAVE paper for class NEET paper from class 11 to 12. So the first question, a car moves a distance of 200 meter. It covers first half distance at speed 40 km per hour, second half of the distance at speed v. Average speed is given to us here. Okay, now how do we define average speed? Average speed is defined as total distance by total time. Now, here the question clearly states that let us say he is going to start from A to B. Now, this distance, half the distance is the midpoint. So, this point is C and this is 100 meter, this length. And this length is also 100 meter. He covers this length with a speed of 40 kilometer per hour. That's what the question states. And this with a speed of V. Now, from A to C, let us say time is t1. We know that time is distance by speed. So, distance is 100 meter. Like we can write that as 0.1 kilometer by speed of 40 kilometer per hour. Similarly, this time is say some t2. Then the t2 value is going to be the distance 0.1 kilometer by speed v. Now, average speed is given as 48 kilometer per hour. That is total distance, which is 200 meter, which is 0.2 kilometer by total time. Here is T1 plus T2. So 48 is equal to 0.2 by 0.1 by 40 plus 0.1 by V. Let's take the 0.1 outside. 1 by 40 plus 1 by V. This goes twice. We'll be left with 2 into 40V by 40 plus V. Now we can cross multiply. We'll get 48 into 40 plus V is equal to 80V. So we are left with 48 into 40 is equal to 80V minus 48V. So this difference is going to be 32. So let us simplify this. It's going to be 48 into 40 by 32. This is 4 eighths. This is 4 twelves. This is 4 twos. This is 4 threes. So we'll be left with 3 into 20, which is 60 kilometer per hour. Hence, this is the value of V. So we just took the definition of average speed and figured out the solution. I hope all the steps are clear. So this is the answer. Two cars P and Q start from a point in a straight line and their positions are represented by these functions. Okay, position of P as a function of time and position of Q as a function of time are given to us. At what time do the cars have same velocity? Okay, so here position of P as a function of time is given as AT plus BT square, and position of Q as a function of time is given as FT minus T square. Now we know that velocity is the rate of change of position. So we can get the velocity of P as a function of time as d by dt of the position function. That is d by dt of at plus bt square, which is a plus 2bt. Similarly, velocity f of q is rate of change of the position vector again. So d by dt of ft minus t square. That gives us f minus 2t. Now we need to figure out the time when these two quantities are going to be equal. So we get a plus 2bt is equal to f minus 2t. To get the 2t term this side, f minus a. So t into, okay, we can take 2t common here, not just t. That gives us that t is f minus a by 2 into b plus 1. And that is our answer. Okay. Now, third one. The displacement x in meter of particle of mass m moving in one dimension under the action of a force is related to time by this. Okay, the position is given. You can get the time from the position here. So the displacement of particle when velocity is 0 will be. Now, to get the velocity, we need to figure out the position as a function of time. And how can that be done? We have been given t is root x plus 3. We can rearrange this as root x is equal to t minus 3 or x is t minus 3 whole square. That gives us t square minus 60 plus 9. Now we can easily find out the velocity because we now have the position as a function of time. That is going to be 2t minus 6. So velocity becomes 0 at time 2t minus 6 0. Time is 3 seconds. And when time is 3 seconds, what is position? X is t minus 3 whole square. X is 3 minus 3 whole square, which is 0. So at the instant when the velocity of body becomes 0, the position of body is also 0. Displacement of particles. Okay, let's continue. Which of the following curve does not represent motion in one dimension? What is one-dimensional motion? A body is moving in a straight line. It can either go in this direction or in the opposite direction. But wherever the body is in its one-dimensional motion, or any motion for that matter, at a particular time instant, the body can only have one value of velocity. At one instant, it cannot move like this and like this and like this. That will not happen. At a given time instant, body can have only one value and direction of velocity. So it can only have one velocity vector. Now, if we draw a vertical line anywhere on this graph, you see, for any time instant, there's only one value of velocity, which means it is okay. Correct. But in option B, if we draw a vertical line, you see this vertical line intersects the curve at 2 points, one point here and one point here at the same time instant t. And is that possible? Is that allowed? Is it physically possible? So at the same time instant t, the body is having two velocities, which is incorrect. It won't happen. So option B is the wrong option. We'll also check option C and D anyway. Here also, if you draw a vertical line, it touches the graph at exactly 1 point everywhere. Therefore, it is correct. Similarly, in option D also, draw a vertical line anywhere, it will touch the curve exactly at 1 point only. Hence, option D is also correct. Only B is incorrect. Okay. Fifth one. The velocity time plot of the motion of body is shown below. So here, okay, the acceleration time graph that best suits this situation. Now we know that acceleration is rate of change of velocity. And that rate of change of velocity is given by slope of velocity time graph. So if we look at the graph here, from this time instant to this time instant, this is a straight line. And we define straight line as a curve with a constant slope. So from here to here, the slope is constant which means the rate of change of velocity is constant. That makes the acceleration also constant. So whatever this time may be, it has one value of acceleration. So if you look at the options here, this acceleration is increasing, incorrect. Increasing, not possible. Here, the value of acceleration is constant for a time interval. So this could be a valid option. Here also, it is constant. But you see here, the slope is also positive, which means acceleration value is positive. See, the body is speeding up from 0 to some value, isn't it? Which means acceleration has some positive value. So here it is negative. The starting value is negative, which rules out option D also. So the only valid answer looks like it's option C, but let's still verify. Now, next, it acquires some maximum speed and then it continues at that maximum speed for a while. So you see here, the velocity is not changing with time, which means acceleration is 0. You see the value of acceleration is 0 for a time interval. And then again, in this time interval, now acceleration is decreasing with time. But again, this is a straight line, so constant slope, so constant acceleration. But because the body's speed is decreasing with time, we can say that the body is decelerating. That is, the acceleration is now negative. So you see, it's first a constant value but positive, then 0, and then a constant value but negative. So only option C suits is the correct curve for this velocity time curve. Okay. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to v of x is beta x power minus 2, where beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by. Oh. So here we have been given the velocity function. Velocity as a function of position is beta x power minus 2n. Now, we know that acceleration is given as rate of change of velocity. We are going to adjust this a little bit. Now, we also know that velocity is given as rate of change of position, or we can keep it as dx. So from here, we can say that dt is dx by v. We're going to use that in the function of acceleration. A is dv by, instead of dt, it's going to be now dx by v. So that gives us v dv by dx. Now, from here, we can say that dv by dx is d by dx of beta x power minus 2n. That gives us beta minus 2n into x power minus 2n minus 1, which is minus 2 beta n x power minus 2n minus 1. Now, acceleration is velocity into dv by dx. Velocity function is this value. As it is, we can take it down. Beta into x power minus 2n. Then dv by dx is minus 2 beta n x power minus 2n minus 1. So that gives us minus 2 beta square n. If we add the powers of x, that becomes minus 4n minus 1. Is that available in the options? Minus 2n beta square minus 4n minus 1. Hence option D. That's what we just got, see? That's how we do question number 6. Question number 7. If a ball is thrown vertically upwards with a speed u, the distance covered during the last t seconds of its ascent is. Last t seconds of its upward motion. Now, the value of u, that's the only thing we know. Let us say the ground is somewhere here. The body is given an upward velocity of u like this. The body maybe goes all the way like this and comes to rest here. So this is the maximum height. And it reaches the maximum height in a time of t equal to u by g. That we know. How do we know that? We know v equal to u plus at, and at the highest point, the body comes to rest momentarily. 0 is equal to u minus gt. So t is u by g. This t is the time of ascent. This is how much time the body takes to reach the maximum height. Now, the question asks us what is the distance covered by the body in the during the last t seconds. Last t seconds means maybe the body is now somewhere here and from here to here. So this, let's keep this as time of ascent. This is time of ascent, let us say. So this time interval is t seconds. And we want to get this distance h. This distance, this is h, let us say. So can we see here if this is some h dash, then can we say that h is maximum height minus h dash, where this whole thing is maximum height? And we've already learned. And how do we get the maximum here? We know v square minus u square is 2ah. At the highest point, velocity is 0. Minus is equal to 2 acceleration minus g. At the highest point from the starting, the displacement is equal to maximum height. So from here we get h max e square by 2g. You can apply the formula directly, that is all you don't remember. This is how we derive that expression. Okay. So h is u square by 2g h max minus this h dash. H dash is what here? The displacement of the particle from beginning till reaches this point. And how much is this time? This time interval is going to be total time of ascent minus this time interval. So can we say that it is displacement in time interval ta minus t? And how much is that going to be? We know displacement s is equal to ut plus half at square. U here is this u. Time here is time of ascent, so u by g minus t. I'm directly putting instead of a u by g. Okay. Plus half. Acceleration here is going to be minus g because the body is going upward. And t square. So ut plus half a t square. Now we have to simplify this. U square by 2g minus u square by g minus ut minus u. Okay, this is minus g by 2 u square by g square plus t square minus 2ut by g. We have to open these brackets one by one. That will give us u square by g minus ut minus u square by 2g minus t square plus ut. So this ut gets cancelled. We have u square by g minus u square by 2g, which is going to be u square by 2g minus t square. Not t square directly. This is gt square by 2, right? So this term gets cancelled. We are left with g t square by 2. Hence, the height 3 t square. That is our answer. Okay. So I hope the steps are clear. We just found out this h dash from the maximum height and the displacement in the appropriate time interval. Question 8. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta and comes to rest. If total time elapsed is t, then maximum velocity acquired by the car will be. Okay. If we can plot a velocity time graph, that would look something like this. Initially, the body accelerates at a rate of alpha and then it decelerates at some rate beta. So let us say the maximum velocity is some v. If we drop a perpendicular, let this time interval be t1 and let this time interval be t2. Then if alpha is the acceleration, then alpha is going to be v by t1 implies t1 is v by alpha. Similarly, beta is also going to be v by t2. But here beta is negative, but the magnitude is still going to be v by t2. That gives us t2 is v by beta. But then the total time given is t. And that is nothing but the sum of t1 plus t2. So we get t is equal to v by alpha plus v by beta. Plus v is equal to t by 1 by alpha by 1 by beta. So if we calculate this, it's going to be alpha beta by alpha plus beta into t. That gives us the value of maximum velocity. Hence, this will be our option. Okay. Moving on to the next one. Preeti reached the metro station and found that the elevator was not working. She walked up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up the moving escalator. Now, let us say escalator looks something like this. This is a rough diagram. Let us say the length of the escalator is some L. If only Preeti is walking, speed of Preeti is some Vp, right? That's going to be equal to the distal length of escalator at time taken t1. That's what the question says. When Preeti walks on the stationary escalator, her time is t1. Similar, but if she is at rest and the escalator is moving, then she goes up in time t2, which means the escalator covers a length of L in time t2. Now, what happens when both escalator and Preeti both are walking? So now Preeti is walking on the moving escalator. The escalator goes up and she also walks on the escalator. What does that mean? She's now going to reach the destination much more quickly. So then total speed is going to be speed of Preeti plus speed of escalator. So when they are both moving, let us say they take a time of t to cover the length of the escalator. Then we get L by T1 plus L by T2 is L by T. The L gets cancelled. We are left with L. 1 by T is 1 by T1 plus 1 by T2, which is T1 plus T2 by T1 T2. So we get total time taken for her to go up when she is walking the moving. this T1 T2 by T1 plus T2. Okay, B. Let's continue. If a unit vector, what do you mean by unit vector? A vector whose magnitude is 1. That is called a unit vector. So that vector is represented by this value, this one, this vector. Then the value of C is. So question 10. The unit vector is given 0.5 I cap plus 0.8 J cap minus CK cap. Now this magnitude is given as 1. This is unit vector. So how do we get the magnitude of a vector? We square all the components, 0.8 square plus minus C square under root. This root is equal to 1, which means the sum of all the squares is also 1. Or we can square on both sides. We get 0.5 square is, okay, 0.5 square plus 0.8 square plus C square is 1. 0.25 plus 0.64 plus C square is 1. So C square is 1 minus 0.25 minus 0.64, and this value is 0.11. That gives us C is 0.11 under root. That is the magnitude of C, the value of constant C. The magnitude of vectors A bar, B bar, and C bar are 3, 4, and 5 units respectively. If A bar plus B bar equal to C bar, angle between A bar and B bar. If you are very keen, you might observe something that 3, 4, and 5 are Pythagorean triplets, which means that kind of might look like this triangle might look like a right angle triangle. The angle might be 90 degree. Let's verify that if that could be true. So question 11, A bar plus B bar is C bar. So if A bar is something like this and B bar is something like this, then the sum A bar plus B bar would look something like this. This is A bar plus B bar, which is C bar. Now, the magnitude of A is 3 units, B is 4 units. This is a right angle. So obviously we will get C bar vector magnitude 5 units. So that says that the angle between A bar and B bar is going to be 90 degree or pi by 2. So either we can directly look at the value and say it is pi by 2. But what if you don't figure out that these are Pythagorean triplets? Then how will we do the problem? If for whatever reason you could not figure out that they are Pythagorean triplets, then we can approach the problem this way. So let's square on both sides. So we get A bar plus B bar magnitude is equal to C bar magnitude. Now let's square it. That will be more clear. That will be magnitude of A square plus magnitude of B square plus 2 times A bar dot B bar equal to magnitude of C square. Let's substitute the values. This is 3 square. This is 4 square equal plus 2 times A bar dot B bar is 5 square. So if we simplify this, we get 2 A bar dot B bar is going to be 25 minus 9 minus 16, which is 0. So we get A bar dot B bar equal to 0. So which means mod A bar. So mod A, mod B, cos theta is 0. A and B values are not 0, which means cos theta is 0. That means the angle between the vectors is 90 degree. Okay. So we can directly solve it using the properties of right angle triangle, or we can square, use dot product and figure it out. Okay. Either way, the answer is the same, it is 90 degree, pi by 2. The position of a particle is given by r bar equal to 40 I cap, 2t square j cap plus 5k cap. Okay. where t is in seconds and r is in meter. Find the magnitude and direction of velocity with respect to x-axis. Okay, at t equal to 1 second. Now, question number 12. The position vector is given as 4t I cap plus 2t square j cap plus 5k cap. Now, then, how will we figure out the velocity vector? It is the rate of change of the position vector. That gives us 4 I cap plus 4t j cap. Since k cap is the k component in the z-axis is constant, there is no component in the velocity vector. So now, what is the velocity at t equal to 1 second? Velocity vector is 4 I cap plus 4 j cap. So what is the magnitude then? This is 4 times I cap plus j cap. So the velocity vector magnitude is 4, 1 square plus 1 square under root, which is 4 root 2 meter per second. But what about the angle made with the x-axis? Let us say it is some alpha, then we get tan alpha is the y component of velocity by the x component of velocity, 4 by 4, which is 1. That gives us alpha as 45 degree. Hence, it's going to be 4 root 2 meter per second at an angle of 45 degree with the x-axis. Next, a man is slipping on a frictionless inclined plane. So frictionless means there is no loss of energy anywhere. And the bag falls down from the same height. The velocity of both is related as. Now, the vertical height from the ground is same, which means the velocities will be same. But let's also prove it. If a body falls from rest through a height h, then the velocity acquired v square minus u square is 2g 2as. In this case, v square minus 0 is 2, acceleration is g, and displacement is say some h. So we get v is 2gh under root. So this is going to be which one? The normal one? Velocity of man, bag. So this is the velocity of bag, which falls vertically from a height h. Now let's look at the man who slides down the inclined plane through the same height h. So this is some theta. Let us say the height of the incline is some h. The man, again, the man is here. He starts from rest. So by the time he comes here, let us say he has velocity of v man. Now, so the man only has a displacement along the inclined plane, and gravity acts vertically downward this way. So if we break down the components of gravity, we get one component perpendicular to the incline as g cos theta, and one component along the incline of g sin theta. Again, let's apply v square. Let us also, before we do that, let us say that the length covered on the incline is some L. Then sine theta is h by L, implies L is h by sine theta. So we are saying that this length through which the man falls the incline is L. Okay. Then let's apply v square minus u square is 2as, but we're applying this equation now along the inclined plane. So v square, this is Vm, we'll put it as m later on, is 2, the component of acceleration down the incline is g sine theta, and the displacement is just L. So v square is 2g sine theta into L. Now let's substitute for the value of L in terms of h, that is h by sine theta. The sine theta gets cancelled. We are left with v square is 2gh. So velocity of man is root over 2gh. So do you see that both the values are equal? Hence, that is the answer. Okay. Question number 14. Two boys are standing at the ends A and B of a ground where AB equal to A. So let us draw what that would look like. So let us say this is point A, and from here this is, say, point B. And this length is some A. The boy at B starts running in a direction perpendicular to AB with a velocity v1. So let's say he's running like this with a speed of v1. The boy at A starts running simultaneously with the velocity v. So let us say he runs like this. This velocity is v. Okay. And catch other in a time t. So let us say this point is P and they are at P at time t. Right? At time t. So he's asking us to find that time t when the boys will meet. So you see here, we know that distance is velocity into time. So we can say that BP is going to be V1 into T and AP is going to be V into T. But what we have here is a right angle triangle. So then we can say that AP square will be AB square plus BP square. So AP square is V into T. AB square is A square and BP is V1T whole square. So that gives us V square minus V1 square T square equal to A square. So T square is A square by V square minus V1 square. That gives us T is equal to A square by V square minus V1 square whole under root. That is our answer. Okay. Question 15. A projectile is fired at an angle horizontal. The elevation angle of projectile at its highest point as seen from point of projection. So let us draw what this might look like. Let's say x-axis is here, y-axis is here. A body is given some velocity u at an angle of 45 degree with the horizontal. So the body's trajectory might look, say, something like this. Right? Now, let us say that this is the highest point and here the velocity clearly is horizontal u cos theta. Now let this height, so this height is going to be the body's maximum height. Then this horizontal distance is going to be half the maximum horizontal displacement, which is half the range. Now the question asks us what is the elevation angle. So the elevation angle from, this is the point of projection. So from this point to the maximum height, this Z line. So we need to figure out this angle alpha. This is the angle of elevation from the point of projection to the maximum height of the projectile. So in this right angle triangle, clearly this is a right angle triangle. So we observe that tan alpha is height by r by 2. We can write that as 2h by r. And for a projectile, the maximum height h is given by u square sine square theta by 2g. And range is given by u square sine 2 theta by 2g. We can expand for sine 2 theta as sine 2 sine theta cos theta and write that as 2u square sine theta cos theta by g. This is g. Then tan alpha is going to be u square 2u square sine square theta by 2g by 2u square sine theta cos theta by g. This g gets cancelled, u square gets cancelled, 2 gets cancelled, one sine term also gets cancelled. And we are left with sine theta by 2 cos theta. But sine theta by cos theta is going to be tan theta. And here theta is 45 degree. That makes tan theta 1, tan alpha 1 by 2 implies alpha is tan inverse 1 by 2. Okay. Question number 16. The maximum range of a gun of horizontal terrain is 16 kilometer. G is 10 meter per second square, then muscle velocity. Now, we have been given the maximum horizontal range. We know that range is u square sine 2 theta by g, and the maximum range occurs when the angle of projection is 45 degree, and that value is u square by 2g. Now, this u square by 2g is given to be 16 kilometer, that is 16 into 10 power 3 meter. So if we take g as 10 as given, that will give us u square is 16 into 10 power 3g, which is 16 into 10 power 4. That gives us u is 4 into 10 square meter per second. So u is 400 meter per second. But what we are finding out here is the velocity of the bullet. Then how can we find the muzzle velocity of the shell? So you see, every bullet is encased in a shell, and the shell would look something like this. It's around the bullet, kind of like that. Now, when the bullet goes ahead at some speed, the muzzle, the shell, which is very light compared to the bullet, will also recoil backward at the same speed. And that recoil speed of the shell is what we call the muzzle velocity of the shell. And that is 400 meter per second. Okay. Question 17. In the given figure, A per meter per second represents the total acceleration of particle moving in the clockwise direction in a circle of radius r 2.5 meter. Okay. So if we get the component of this acceleration radially inward, that is going to be A cos 30 degree, and perpendicular, that is tangential, that component would be A sine 30 degree. Now, this tangential component is what we call tangential acceleration, and this radial component acting inwards is called the centripetal acceleration. So now here we have AC as A cos 30 degree. But centripetal acceleration is given as V square by R, where V square is the speed of the body at that instant. So we get V square is A into R into cos 30 degree. Let's substitute these values. A is 15 meter per second square, R is 2.5, and cos 30 is root 3 by 2. If we calculate, if we substitute 2.5 as 5 by 2, this becomes 75 by 4 root 3. So on taking square root, we get 75 is 25 into 3. So that gives us 5 by 2, 3 root 3 under root. Now, if we substitute the value of root 3 as 1.732 and calculate this square root, that value comes close to 5.7 meter per second. Okay, so that is our answer. Question 18. Two particles of mass capital M and small m are moving in a circular path having radius r and small r. Their time periods are same. The ratio of angular velocity. Now, we define angular velocity as angular displacement by time. Now, when the angular displacement is 2 pi, that is the body has covered one rotation, we say the time passed is one time period. So then we can say that omega is nothing but 2 pi by t, which means time period is 2 pi by omega. Now, the question states that the time periods are same for both the masses. So we can write this as 2 pi by omega for capital M, and this is 2 pi by omega for small m. The 2 pi gets cancelled and we are left with omega m equal to omega small m, which means the ratio is just 1. So equal time periods correspond to equal angular velocities. Now, question number 19. The force acting on a particle of mass m is indicated by the force time graph as shown. The change in momentum of the particle over time interval from 0 to 8 seconds. Now, From Newton's second law, we know that force is equivalent to rate of change of momentum. From here, we can say that the change in momentum is force into delta t. This is nothing but area under the force time graph. So let's find the area here. So we have, this is area 1, let us say this is 2, let us say this is 3. So area 2 here is below the x-axis. So that corresponds to a negative area. And then we have area 3 as usual. That is going to be half. Area 1 is a triangle, base into height. Area 2 is a rectangle, 2 into 3. And area 3 is again a rectangle, that is 4 into 3. So this is 6. So this is going to be just 12. 12 Newton second. That is the change in momentum. Now, question number 20. A stone is dropped from a height h. It hits the ground with certain momentum p. If the same stone is dropped from a height 100% more than the previous height, momentum when it hits the ground will change by. Okay. So let's say initial height h1 is some h. Then when it is dropped, which means the initial velocity is 0. It acquires a velocity of say v1, which will be equivalent to root over 2gh. Then momentum is going to be m into root over 2gh. Now, the height is increased by 100%, which means it is initial height h1 plus 100% of h1. And that is just h1. So we have now the new height is double the previous height. So the velocity it acquires after it falls through a height of 2h is going to be root over 2g into 2h, which is root over 4gh. Then the momentum acquired by the body is going to be m into root over 4gh. Now the question asks is the momentum, the percentage change in the momentum. That is change in momentum by initial momentum into 100. That is going to be P2 minus P1 by P1 into 100. This P2 is going to be m root over 4gh minus P1 is m root over 2gh by P1 into 100. M gets cancelled, root over gh also gets cancelled. We are left with root 4 minus root 2 by root 2 into 100. This comes down to root 2 minus 1 into 100. And root 2 value is 1.414. Subtract 1, it becomes 0.41. So it is 41%. That is the change in momentum. Okay. Let us do this 21st question. Sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving at a constant velocity. Now, we have learned about Newton's second law. Newton's second law states that force is equivalent to the rate of change of momentum. So, force is rate of change of momentum. Now, momentum is the product of mass into velocity. So, force can be written as d by dt of m into v. Now, if we expand this, this is going to be m dv by dt plus v dm by dt. Here, velocity is constant. That is given in the question. That means the value of dv by dt is going to be 0. From here, we can conclude that f is just velocity into rate of change of mass of the body. Now, you see here, the question says that it is the mass is increasing on the conveyor belt at a rate of m kg per second. Because, see, sand is dropped at m kg per second, which means mass on the conveyor belt is also increasing at m kg per second. So here, the rate of change of mass is capital M kg per second. Therefore, the force is just going to be velocity into this capital M. mv Newton. This is small v. Okay. Question number 22. If the force on a rocket moving with velocity of 300 meter per second is 210 Newton, the rate of combustion of fuel is. So you see the units are kg per second. So what he's asking essentially is how much fuel is being burnt in 1 second. Here also we'll apply Newton's second law and solve the problem. Now we know that force is rate of change of momentum, which is just rate of change of mass into velocity. This can be written as m dv by dt plus v dm by dt. So here they have given a constant velocity for the rocket, which means the speed of rocket is not changing with time. So v is 300 meter per second, implies the rate of change of velocity is now 0. That makes force just v dm by dt. The force given is 210 Newton. The velocity of rocket is 300 units meter per second. Yeah. So that gives us dm by dt is 210 by 300. That is going to be 7 by 10 or zero point 0.7 kg per second. This is the rate at which fuel is being burnt. What we mean here is in 1 second, 0.7 kg of fuel gets burnt. Question number 23. A bullet is fired from a gun. The force on the bullet is given by this function F. Okay. Where F is in Newton, time in seconds. Force on the bullet becomes 0 as soon as it leaves the barrel. So, which means in a very, very small amount of time, the force becomes 0. So, what is the average impulse imparted to the bullet? Question 23. The force function is 600 minus 2 into 10 power 5 time into time. Now, when does the force become 0? So, it comes to rest almost immediately. But how much is that time? However small it is. That is 600 minus 2 into 10 power 5. T is 0. 600 is equal to 2 into 10 power 5t, implies t is going to be 300 into 10 power minus 5. That gives us time 3 into 10 power minus 3 seconds or 3 milliseconds. So within just 3 milliseconds, it comes to rest. The gun comes to rest. Now, what is the momentum imparted to the gun? We know that F is dp by dt. So we can say then that dp is F dt. So we also know that impulse is change in momentum, which is final momentum minus initial momentum. This value is going to be integral F dt. Initially time is 0 till the time 3 milliseconds. I'm just putting it as t for now. So the average impulse imparted, this is the average value. So average impulse is going to be integral 0 to t. F here is 600 minus 2 into 10 power 5 t. This comes out to be 600 t minus 10 power 5 t square from 0 to t is 3 into 10 power minus 3 seconds. So let's substitute the limits. Minus 10 power 5. I'm directly squaring the value. So this gives us 1.8 minus 0.9, which comes to 0.9 Newton second. Or it can be kg meter per second. Yeah, 0.9. This is how we solve the problem. We have been given the function. So we first get the momentum function and we get the average impulse as the change in momentum in this 3 milliseconds. Question 24. A satellite in force-free space. So basically, I think it's vacuum. Sweeps stationary interplanetary dust at a rate of dm by dt is alpha into v, where m is mass and v is speed of satellite. Alpha is some constant. So what is the acceleration of satellite? Okay, so here let us apply Newton's second law again. Second law states that force is the rate of change of momentum. So it is dp by dt. And momentum is what? Just mass into velocity. This can this can be expressed as m dv by dt plus uh, plus v dm by dt. But it is clearly mentioned that it is a force-free space, which means force is zero. Implies m dv by dt plus v dm by dt is 0. And dv by dt here is just the acceleration. So we can keep this as a plus v dm by dt is alpha v. So we get here a is minus alpha v square by m or capital M. That's it. It's just an application of Newton's second law. A particle of mass m is moving with uniform velocity v1. It is given an impulse such that the velocity becomes v2. The impulse. Now, we can also say impulse is the change in momentum. That is the final momentum minus the initial momentum. Here, the body's final velocity is v2. So, final momentum is mv2 and initial velocity is v1. Hence, initial momentum is mv1. Hence, the total impulse given is just m into v2 minus v1. Question 26. An object flying in air with velocity 20 I cap plus 25 j cap minus 12 k cap suddenly breaks in two pieces whose masses are in the ratio 1 is to 5. Smaller mass flies off with velocity 100 I cap plus 35 j cap plus 8 k cap. So velocity of larger piece. So you see it breaks suddenly on its own. There is no external force causing the breakage to happen. What that means is that the body's momentum remains conserved. We're going to apply conservation of momentum here. So the mass ratios are 1 is to 5. So if total mass is 6m, one part has a mass m and the other part has 5m. So 6m mass has initial velocity of 20 I cap plus 25 j cap minus 10 k cap. Now this is the body's initial momentum. So we can write this as initial momentum. Now, after the body breaks, it'll have a final momentum. Now, the lighter piece has a mass of m and the velocity is 100 I cap plus 35 j cap plus 8 k cap. And the other heavier mass, let us say, has a velocity vector of v bar. So here, the body's initial momentum and final momentum are going to be the same because momentum is conserved. So let us substitute them. So 6m into 20 I cap plus 25 j cap minus 12 k cap is equal to m 100 I cap plus 35 j cap plus 8 k cap plus 5m v bar. Now this m can get cancelled. So if we take these terms to the other side, we get 5 v bar is 120 minus 100 I cap plus 6 into 25 is 150 minus 35 j cap plus 6 into 12 is going to be minus 72 minus 8 k cap. This comes out to be 20 I cap plus 115 j cap minus 80 k cap. But this is 5 times the velocity vector. So V bar is going to be 20 I cap plus 23 j cap minus 16 k cap. Okay, this is 4, not 20. 4 I cap plus 23 j cap minus 16 k cap. This is just an application of conservation of momentum. We just equate the body's initial momentum to the body's final momentum. 27. A block A of mass m1 rests on a horizontal table. A light spring connected to it passes over a frictionless pulley at the edge of the table, and from its other corner, another block B of mass m2 is suspended. The coefficient of kinetic friction between block and table is mu k. When the block A is sliding on the table, tension in the string. Let us first draw a figure to describe how this might look like. So let us say this is a table. Yeah. So we have say a pulley like this. So the block is here. This happens to be M1 passing over the pulley. Similarly, another block M2 passes over like this. Now, this is rough with the coefficient of kinetic friction mu k. Now, this system has some acceleration downward. Let us say acceleration is A. And the tension in the string is going to act horizontally on M1 and upward on M2. Now, if we draw the FBD of M1, we're going to get something like this. There's a tension this side, and then there is kinetic friction. And the value of kinetic friction is going to be mu k mg. And the body has a net acceleration A to the right. So we can say that tension minus mu k mg equal to m1a. Now, if we draw the FBD for m2, we have an upward tension acting. Downward, we have the body's own weight. And then the accelerates down with A. So for M2, the equation is going to be M2G minus T is equal to M2A. Now let's multiply this whole equation with M2 and this whole equation with M1. Let's see what we'll get. M2T minus, this is M1G, mu K M1 M2G equal to M1 M2A. Here on the same lines, we are going to get M1 M2G minus M1T equal to M1 M2A. Do you see these two are equal? So we can equate the LHS or both the equations now. So we get M2T minus mu K M1 M2G equal to M1 M2G minus M1T. So get the tension terms on one side. We'll get M1 plus M2 into T equal to M1 M2G into 1 plus mu K. So tension on the string becomes M1 M2 by M1 plus M2G into 1 plus mu K. And that is option A. Okay. We are just writing the equations of motion and simplifying them. 28. A block of mass m is in contact with the cart C as shown in the figure. The coefficient of static friction between the block and the cart is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. Now you see the cart will obviously move horizontally along with the cart, but it's not going to fall down. So in the reference frame of the accelerating cart, the mass m is at rest. So in the reference frame of cart, the FBD of the mass is going to look something like this. We are going to have its own weight acting vertically downward. This surface is rough, so we have a friction acting upward. And because it is in contact, there is a normal reaction here. But then since since the cart is accelerating to the right, it will experience a pseudo force like this of MA. This is a pseudo force. So here, since it is in equilibrium horizontally, because in the frame of the cart, it's at rest. So we can equate normal reaction to pseudo force. Now the body will not slide if the value of friction is greater than or equal to mg. See, what is he asking us? The acceleration alpha to prevent the cart from sliding. Okay, this is alpha, not A. So from here, friction value is how much? Mu n greater than or equal to mg. But then this normal reaction is m alpha. The m gets cancelled. We're left with alpha greater than or equal to g by mu. That is the inequality. We just applied the concept of pseudo force because the mass m is going to be going to be at rest with respect to the cart. A car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is s. The maximum safe velocity on this road is. So let us say the road is something like this. Okay. This angle is some theta. Now the car is somewhere here. Since the car is going really fast, its tendency is to go fly away like this. To prevent that, friction is going to act downward to prevent the skidding of the tires. Okay. Now normal reaction acts something like this, perpendicular. Now we can break normal reaction into its components, but first of all, let us draw the so we have something parallel to the horizontal here and parallel to the vertical here. Now, if we take the components, if you observe, this angle is also going to be theta. This angle is going to be theta. This angle is also going to be theta. So if we take the components of normal reaction, we get one component here, n cos theta, another component here of n sin theta. Similarly, if we take components of friction, we get one component here, f cos theta, and a downward component of f sin theta. If the body is just in equilibrium, we can say that n cos theta is equal to mg plus f sin theta, which means n cos theta equal to mg. Horizontal direction, we have two components of forces acting inside towards a circular motion. So we get here n sin theta plus f cos theta. These two forces are what provide the necessary centripetal force required the body turning. So this is going to be mv square by r. This v happens to be v max. So we get here this limiting friction is going to be mu into normal reaction. So then we get normal reaction is going to be mg my 1 minus mu sine theta, right? So this is going to be cos theta minus mu sine theta. Now, if we substitute this equation here by cos theta minus theta into sine theta plus normal is what we can do is write this as mu n cos theta equal to mv square by r, and sine theta plus mu cos theta is mv square by r. Now normal reaction we just found out mg by cos theta minus mu sine theta. Sine theta plus mu cos theta is mv square by r. This m gets cancelled. Here we can do something. We can take cos theta common also. And we get here cos theta cos is tan theta plus mu. So here also take cos theta common. We get here 1 minus mu. This will get cancelled. V square by r. So we are left with v square is equal to g into r mu plus tan theta by 1 minus mu tan theta. So that will give us v. So you see it is this value. mu plus tan theta by 1 minus mu tan theta. So V is GR mu plus tan theta by 1 minus mu tan theta. That is the maximum safe speed. If you have to figure out the minimum safe speed, friction will be in the opposite direction. So friction would be like this. But since he asks us the maximum speed, we know friction is trying to prevent the wheels from going to the side. So that is how we solve this problem. Question number 30. A balloon with mass m is descending down with an acceleration a, where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration of a? You would have to move up this. So there's mass m here. There's some upward force acting. There's weight acting down with a, which means mg. Now, some m dash is removed. Mass is just m minus m dash. The net force acting upward is the same, but now the weight has reduced. It's m minus g. Use such that the body is now accelerating. So then we can minus m dash g m dash into a. So if we add both these equations, we can eliminate the term dash. We will get mg minus dash g is ma plus m minus a. The mg term gets cancelled, we get m dash 2 ma m dash a plus m dash a is, oh wait, m dash a. So how much you have to do is 2ma by g plus a. If vector a bar and b bar are functions of time, then the values they are orthogonal to each other. Orthogonal means they are perpendicular to each other. When two vectors are perpendicular, the dot product is going to be 0. So we're going to apply that condition here. Consider a drop of rain having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 2 meters per second. Taking g constant, the work done by gravitational force and resistive force of air. Okay. Question 32. Work done by gravity is just going to be mgh. And it is positive because the body is coming down. So mass of the body is 10 power minus 3. G is 10, height is 1 kilometer, it's 10 power 3 meters. So it's just 10 joules. So this work done by gravity can be equated to the loss in potential energy. Right. So the potential energy, the decrease in potential energy is equivalent to increase in kinetic energy plus work done by resistive force. So this work, W, the work done by resistive force, frictional force, is now the loss in potential energy minus the kinetic energy gained by the body. So half m v square. That is 10 minus, this is going to be 25. This comes out to be approximately, this comes out to be 1.25 if you simplify it. That is 8.75. Yeah. But this is the magnitude of work done. You see, the drop is falling this way. So displacement vector is like this, but the force acts in the opposite direction. So this is actually magnitude of work done. So work done is going to be minus 8.75 joules. We are finding this out by using the conservation of energy here. Okay. What we have here is the magnitude, not the actual value of work done. The actual value of work done would be negative because the displacement is against the direction of force. Hence, the answer is going to be 10 and minus 8.75. A body moves with a constant speed along a circle. Constant speed means v is constant, but you see, work done on it is work. No work done on it. That is true. How is that true? Because the only force acting on the body is centripetal force, and the displacement of body is perpendicular, which means the work done by centripetal force would be zero. So no work is done on it. No acceleration produced is not true. There is always centripetal acceleration acting towards center. Its velocity remains constant. Also not true. The body's speed remains constant, but since the body is moving in a circle, the body's direction is constantly changing, which means the velocity is constantly changing. Obviously, there has to be some force to maintain circular motion. So this also is false. Only option A is correct. A particle of mass 5m suddenly at rest suddenly breaks into its own on its own into three fragments. Two fragments of mass m each move along mutually perpendicular directions with speed v each. So energy released during the process. Now see, initially the body is at rest, but the momentum initially is zero. The kinetic energy of body also initially is zero. Now this is the horizontal. It makes equal angles like this. So the one momentum is like this, other momentum is say like this, such that this angle is 90. So the more appropriate figure would look something like this. So this is also 45 degree. This also is 45 degree. Now the third component of mass 3mv would move like this. Let us say its velocity is 3mv dash. The momentum is 3mv dash. So if we break the components of this, we'll get here mv cos 45, and this component is mv sine 45. Similarly, this also becomes mv sine 45, and this is again mv cos 45. So this will get cancelled. So we can conserve momentum now. We get 3mv dash is 2 times mv cos 45 degree. So m gets cancelled. We get v dash is equal to 2 by 3 v by root 2. That will give us root 2v by 3. Now we need to get the energy. Energy released during the process. Energy release is nothing but the final kinetic energy of all the masses. That is half mv square, the other half mv square, and then half 3m. The velocity here is root 2 by 3v square. That will be now mv square plus 3m by 2, 2v square by 9. That will be mv square plus mv square by 3, which is 4 by 3 mv square. Now that is the energy imparted. Energy released during the process. See, initial energy is zero. So whatever energy is released is nothing but the kinetic energy of system after the explosion. And that's what we have found out here. Okay. Question 35. An engine pumps water continuously through a hose. Water leaves the hose with a velocity v, and m is the mass per unit length of the water jet. So what is the rate at which kinetic energy is imparted? Okay. There is a hose, and water leaves the hose with velocity v and mass per unit length of water jet. So if you have some length L, of the water jet, and this water has a mass m, then the mass per unit length is m by L, implies the mass of the water there is m into L, coming off with velocity v. Now, he's asking us what? The rate at which kinetic energy is imparted. So, kinetic energy imparted by delta T. Now, this is what? We can say in a way it is 1 by T half m v square, or we can say d by dt, nothing but the rate of change of kinetic energy. That is a more appropriate way of putting this. Now, the velocity anyway is constant. So this v is anyway a constant value. So we get the half and v square here. This is going to be dm by dt. But then here, what is small m here? Mass, which is the mass per unit length into length. So it's going to be d by dt of m into L. Now this m can come out, it's a constant. And we have now dl by dt. And what is dl by dt? That is going to be the velocity at which water is ejected. So this is going to be half m v cube. That is the rate at which kinetic energy is given to the body, is given to the water. Yeah. Now, question 36. A force acts on a 3-gram particle in such a way that the position of particle as a function of time is given. The work done during the first 4 seconds. The position of particle changes according to 3t minus 4t square plus t cube. Now the velocity then is a rate of change of position. So we differentiate this function to get the velocity, which is d by dt. We can directly write this as 3 minus 4 2's 8t plus 3t square. Now he's asking the work done in the first 4 seconds. So velocity at t equal to 0, velocity is 3 meter per second. Now at t equal to 4 seconds, velocity is going to be 3 minus 4 8 32 plus 3 into 16, 48. That is going to be 16 minus 16 plus 3, 19 meter per second. Now, work done is equal to change in kinetic energy. We have learned the work energy theorem. So it's going to be half, mass is 3 grams, so 10 power minus 3 kg into V. This change in kinetic energy is final kinetic energy minus initial kinetic energy. So 19 square minus 3 square, that will give us half into 3 into 10 power minus 3 into 19 minus 3 is 16, and 19 plus 3 is 22. That will be 8 times. So 66 into 8 into 10 power minus 3. That comes close to 528. So it is 528 millijoule, approximately 530 millijoules. So we just applied the work energy theorem here to get the work done. Okay. Question 37. The potential energy between two atoms in a molecule is given by this function. Okay. We've been given the potential energy function here. The atom is in stable equilibrium when? Now, what do we mean by stable equilibrium? When the energy in the body is minimum, or we can say du by dx is 0 and d square u by dx square is maximum, is negative, sorry. That is when energy is minimum. So we get now d by dx of the function given here is a by x power 12 minus b by x power 6 is 0. So differentiating this, we get a minus 12 by x power 13 minus b into minus 6 by x power 7 equal to 0. So that gives us 12a by x power 13 equal to 6b by x power 7. So we get here 2a by x power 6 is equal to b, implies x power 6 is 2a by b. That gives us x is 2a by b whole power 1 by 6. We just have to differentiate the potential energy function to locate the point of minima. And if you differentiate this once again and substitute this value there, you will get a negative value, showing that that is the point of minima. That is, it is a stable equilibrium. Question 38. A stone is tied to a string of length L and is whirled in a vertical circle with the other end of string as the center. At a certain instant of time, the stone is at its lowest position and has a speed u. The magnitude of change in velocity as it reaches a position where the string is horizontal. Okay. So initially string is down like this and the velocity is u. So gradually the body went like this and it reached somewhere here where the velocity is now vertical and it is v. The string is now like this horizontal. He's asking us to get the change in velocities. So if you see here from the conservation of energy, we can say that initial kinetic energy is used up to increase the potential energy and the remaining is kinetic energy at that point. So we then get V square is U square minus 2GL. Leave it at that. Now the final velocity vector is going to be this Vj cap. Initial velocity vector is Ui cap. So we want the change in velocity, which is the final velocity minus the initial velocity. And we want this magnitude, that is going to be magnitude of Vj cap minus Ui cap, which is going to be V square minus U square. And V square is already U square minus 2GL V square plus U square, sorry. So then this becomes 2U square minus 2GL under root. That is 2 into U square minus GL under root. And that's the magnitude of change in velocity. This is the length L of the string. Yeah. Question 39. As shown in the figure, a mass is performing vertical circular motion. The average velocity of particle is increased. Then, at what point will the string break? Now, when will a string break? String breaks when tension is very high, tension is maximum, and in vertical circular motion, tension is maximum at the lowest point in the circular motion. So if we increase the velocity here, the tension by the time the body reaches the lowest point B is going to be so high. And if it is incredibly high, the string might even break when the body comes to B. Hence, B is the answer. Because tension is maximum at B, lowest point in the vertical circular motion. Question 40. A vertical spring with force constant K is fixed on a table. A ball of mass m at a height h above the upper free end of the spring falls vertically on the spring so that the spring is compressed by a distance d. The net work done in the process. So let us say the mass is somewhere here, m. The spring is somewhere here. Such that this height is some h. Now, as it falls, it's going to say come till here such that the spring is now compressed by some x. So the net work done in the process. So you see here, total work is done by gravity when the body falls, and then once the body hits the pan above, hits the table fixed to the spring, then there is spring force also. So work done by gravity is just mg h plus x, and work done by spring is going to be half k. Okay, compressed by a distance d, right? Okay. So then it is mgh plus d and half k d square. Work done by gravity plus work done by spring force is the net work done in the process. A block is released from rest from a point P having coordinates -9, -9. 9, okay. It slides down along a fixed smooth parabolic path shown in the figure. Given that mass of ball is 5 kg and normal reaction. Okay, so we have to get the normal reaction as it reaches the bottom. Let us say it acquires some velocity v at the bottommost point. It starts from here. It has fallen through a vertical height of 9 meter. So from the conservation of energy, it starts from rest. So there's initially no kinetic energy. The loss in potential energy of the mass is equal to its gain in kinetic energy. So we get V is root over 2gh. Substituting the values, we get 2 into 10 into height of 9. So velocity is root over 180 meter per second. Now, at this point, there is a normal reaction acting upward like this and weight acting downward, but the body seems to have a circular path. So then we can say that normal reaction minus mg is mv square by r. Now here we don't know the radius of curvature of the path at the lowest point is not known to us. Now, to get what is the coordinate of the lowest point? It is just origin, so 0, 0. So how do we get the radius of curvature? The expression for radius of curvature is 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square magnitude. Now here the equation given to us is y equal to x square by 9. So we get now dy by dx is 2x by 9 and d square y by dx square is 2 by 9. Now at 0, 0 at the point we are taking, we have dy by dx being 0 and d square y by dx square, which is anyway constant, is 2 by 9. So substituting this, we'll get radius of curvature is going to be 1 plus 0 by, this is 2 by 9, which is 9 by 2 or 4.5 meters. So now we can get the normal reaction. Normal reaction is mg plus mv square by r. Now given that the mass of particle is 5 kg. So normal reaction is mg plus mv square by r. So this is 5g10 plus again 5. V square is 180 by this is 9 by 2. So that gives us 50 plus 5 into 2 into 20. So 50 plus 200. So normal reaction is going to be 250 newtons. So if you know how to get the radius of curvature, this problem would be very easy. Question 42. Two springs A and B having spring constants Ka and Kb, where Ka is twice Kb, are stretched by applying force of equal magnitude. If energy stored in spring A is Ea, energy stored in spring B will be, okay, question 42. Spring constant of A is twice the spring constant of B. Now we're applying the same amount of force and we know that force is spring constant into elongation in the spring. So for A, the elongation is going to be F by Ka, which is going to be F by twice Kb. Similarly, for spring B, it's going to be Kb into Xb. So elongation in the spring B is going to be F by Kb. Now, energy stored in spring A is half Ka Xa square, which is half Ka is anyway 2 Kb, and Xa is F by 2 Kb whole square. That gives us F square by 2 into 2 Kb. Similarly, Eb is half Kb Xb square. That is going to be half Kb we found Kb. Xb we found out as F by Kb square, which is just F square by 2 Kb. So taking the ratio, we get Ea by Eb is 1 by 2, implies Eb is twice Ea. Okay, this is Ka only, no? Question 43. Water falls from a height of 40 meter at a rate of 15 kg per second to operate a turbine. The losses due to frictional force are 10% of the input energy. So how much power is generated by the turbine? So in 1 second, 15 kg of water will fall, and all energy of water is getting converted into the kinetic energy of the turbines with 10% loss. Okay. So the height is 60 meter and it is 15 kg in 1 second. So here the loss in potential energy is what is energy gained by turbine. So that is mg into h, that is 9,000 joules, but 10% loss implies actual energy available is only 90% of this. 90% of 9,000 joules in, this is again in 1 second. That is going to be 90 by 100 into 9,000. That gives us 8,100, which is going to be 8.1. This is joules per second, which is 8.1 kilowatt. The loss in potential energy of water is what powers the turbines with 10% loss. So we account for the loss and take only 90% of the potential energy of water. Now, question 44. A particle of mass m is driven by a machine that delivers at a constant power k watts. The particle starts from rest. The force on the particle at time t is. So the body starts from rest, which means initial energy of body is 0. Now power is what? Energy supplied per unit time, which means energy supplied is equal to K into T. Now this energy is nothing but the kinetic energy of the body, implies kinetic V implies half m V square. Okay, we have to get V square. Now V square is going to be 2 kT by m. So here we can get velocity at any instant is at instant t is root over 2 kT by m. But then power is force into velocity, and the question asks us to find the force, which is k by velocity. So force is going to be k by 2 kT by m under root, which is going to be m k by 2t under root. So that is mk by 2 t power minus 1 by 2. We can rewrite this as mk by 2, and this is 1 by root t. This 1 by root t can be written as t power minus 1 by 2. Just a notation. Okay. Question 45. A mass m is moving horizontally along the x-axis with velocity v and collides and sticks to a mass of 3m moving vertically upward along y-axis with velocity 3v. The final velocity of combination. Okay, so initial momentum, here again there is no external force. Momenta will be conserved. Initial momentum is mass m moving horizontally, which means it is moving along the x-axis with velocity v. So mass mv I cap. And then we have 3m moving vertically upward. So along y-axis with velocity 2v, the momentum direction is j cap. Now, finally, when they both collide, they have a mass of m plus 3m and say velocity of v bar. Since there's no external force acting here, initial momentum and final momentum will be the same. So we get mv I cap plus 6 mv j cap is going to be 4m into v bar. So we get v bar is v by 4 I cap plus 6 by 4 v j cap. That gives us v by 4 I cap plus 3 by 2 v j cap. This was just an application of conservation of momentum. So I hope the paper is clear. Thank you.